I'm your host Arpit, and joining me today are Schaun Wheeler and DJ Rich. Well, great to have you here in the studio. Let's begin by talking what really matters when building a recommender system. We've talked about the content that people find when they look for ideas on how to build a recommender system, and the content on Google is pretty cookie cutter. It just talks about, a very high level stuff, doesn't really go into the specifics, right? So what's the first concrete step toward designing a recommender system? Schaun, you want to go?
Yeah, sure. So you have to recognize what kind of business problem the solution is trying to solve for. There's kind of a double-edged sword in data science, that on the one hand it provides a lot of powerful solutions, but on the other hand, people are prone to find a solution and then assume it'll solve a problem without actually identifying the problem and understanding it first. Because recommender systems solve the discovery problem, or they're one solution for solving a discovery problem. You see this anywhere in e-commerce, streaming, gaming, things like that. There's way more options that users could choose from than they can possibly sift through. Like if you go on Netflix, there's lists of videos. It's just unrealistic for someone to go, for their attention span to last long enough for them to go through and find the thing that's actually going to meet what they want and therefore have them use your platform. So a recommender system is one of the ways you can try to skip that decision process and get directly to something that has already been pre-filtered based on someone's preferences. There are a lot of problems that businesses try to deal with that aren't that discovery problem. So I think the first step is recognizing that's the beast you're trying to catch.
Yeah.
And then the rest of it flows from that.
Cool. DJ, what do you think? Do you have anything to add to that?
Yeah, I mean, just to echo a little bit of that, you certainly have to agree on the problem before you agree on the solution. And I mean, this isn't specific to recommender systems in particular. This is sort of like anything that you're going to build within a tech company, but you're going to have sort of these long target goals: growth, profit, revenue, brand recognition, sort of things that can only be measured on a quarterly basis. And then you're going to try to reduce that into a shorter term goal that a recommender system might be able to assist with. So these are like clicks or purchases or watch time or dwell time or whatever it is.
Right.
There is sort of like an ambiguity between those two things where, the big goal and the little goal. So, you agree on the variables that you're going to address. I think you should also agree on what you're going to miss and maybe almost immediately build in follow-up plans to check those assumptions about how the short-term goal connects to the long-term goal. But let's say you do that poorly defined process and you determine ultimately that you're going to invest in a recommender system. One, I'll say, I think recommender systems are one of the highest leverage things that data scientists can invest in. They are just, there's reasons there's so many billions of dollars behind it. So, coming to the conclusion that you're going to build a recommender system, I don't think is the most surprising thing. Then when you're doing that, you have to acknowledge like recommender systems are very complicated. There's a reason there isn't like a productized version of recommender systems that everyone can just plug into.
Yeah.
Startups can't just say, oh, I got my recommender system service over there. It's because recommender systems are they're kind of like a nervous system. They're plugged into every organ. You have to build them because they're so intertwined with your existing system. And there's multiple components to it. A recommender system isn't a recommender model. So you have just you have your item inventory, and then you have your users and features that you have about them and user histories. Then you have like a retrieval system, which is the thing that's going to filter down to the 500 or so items that the recommender system is actually going to rank from or pick from. You have all your instrumentation and logging for finding all the data. You have the UI. There's like all these different components. Ultimately these things have to be separated. You can't have one person doing all of these things,
right.
But you need to anticipate the interactions. So one thing that's clear in my mind is like the interaction between the user interface and the recommender itself. So if you're thinking about Netflix, why did you choose XYZ movie? Well, a lot of it is a function of what else was on the screen. So if I picked X, one dominant reason that I may have picked X is because some other thing that I wanted to see wasn't there as well. So the whole interface is a big component in your decision. That's something to be aware of, at least. That's a kind of a hard piece of information to get in. For AMP, it's messaging, which is conveniently pretty simple. It's just like we're going to send some text and they're going to see it. there's a lot of components to just keep in mind. So, variables, components, and anticipate some complexity.
Thank you. Yeah, that's fascinating. Okay, now let's get into the prerequisites to build and deploy a recommender system, right? We've talked about the high level stuff, but help our audience understand what are the components one needs to sort of build to implement a recommender system from scratch.
So I think DJ already covered a lot of this. I mean, you basically need an item inventory, so whether it's videos or games or shirts, anything like that, and all that is attached to all of your metadata regarding those item IDs. So you're going to have brand names, you're going to have product categories, you're going to have the actual display name, you might have descriptions. All that information can be leveraged in a recommender system. So that's one side. And then on the other side, you have to have, I guess what you could call a consumption history. So this is interactions between timestamped interactions between individual users and individual items. I mean, obvious consumption would be something like purchasing an item, but there's lots of other touch points that you could count as maybe not as strong a signal, but still signal nonetheless. Just viewing an item, adding it to cart, things like that. If that's something that's in your funnel process, a recommender system can make use of that. Once you have those two pieces, the keyed by item ID, all the information that you're going to want to end up displaying when making a recommendation, and then on the other end having that history, then it's not, I don't mean to minimize it, but you then in the middle, that's where the recommendation model happens. You're finding ways, like DJ said, to filter down the item IDs to a subset that you're going to try to decide what to recommend, and then you're using all this information about what users have interacted with what to make the recommendation. One thing that may be worth mentioning, especially for companies that are either in their very young stages or companies that have actually been around for a long time and are trying to modernize their data infrastructure. You might consider whether building a recommender is actually the best option.
Yeah.
If this was like 5 years ago even, I probably wouldn't even be saying this, because the infrastructure has come a long way in just the last few years, where it used to be you needed to have a dedicated engineering team just to handle all of your ingestion and shaping your data into the way you would want it to be. And you would need a lot of engineering capacity to push out information to your website or out into push notifications or anything else, any service you're trying to use to communicate with the customer. But those two kind of pipelining aspects, there is a lot of advancements that have happened in CDP infrastructure, in messaging systems, things like that, that actually make those two pieces, a lot of times you can get a lot of that off the shelf. And the thing is, if you're already getting that off the shelf, which I would recommend, instead of building it yourself, it's a hard thing to build by yourself. But if you get that off the shelf, it seems a little bit silly not to have a recommender system that just, like, you already have the two pieces. You need the model in the middle. You should look for a system that offers a recommender sort of. I mean, that's when we built AMP. We designed a recommender system as table stakes, like that. We expected that if we were going to have the two endpoints, we should have the thing to connect it together in that way. So I don't mean that to be like a plug for AMP, but I think that this. Oh, I didn't know we had the. I didn't know I'd get an ovation for that one, but I think that it's worth considering. It's always worth considering in build versus buy options. Buy actually often makes a lot of sense, because buying one thing frees up your capacity to build other things that you can't buy. And a recommender system is still, as DJ mentioned before, it's still a lot in that space of, it's kind of, you need a bespoke solution for your particular use case. But increasingly, since those two endpoints of ingesting data and moving out messages or content has been increasingly automated, going forward, you really should expect to be able to find a recommender system, at least one to get you started. And then maybe you devote resources later on when you have a better idea of what you want.
Right. DJ, I got to ask you this. You'd mentioned once that there's this thing called the learner, which is an essential component of a recommender system. Do you want to just quickly tell our audience what a learner is?
Yeah, I mean, this is in the context of like a schematic in my mind about what a recommender system involves, and the learner is just the thing that trains your model. We don't really think of it as that distinct because when anyone's writing in a Jupyter notebook, they have their model and then they train in the same run. So the learner and model aren't separate, but in a formal infrastructure, they are kind of different. There's the algorithm that trains the model, generally freezes it, saves it somewhere, and then that frozen model gets deployed later. And in the production system, they're separated. So your mental model, they should be separated. And the learner is going to have other things like its own compute constraints. It's going to have its own retraining periods or whatever. And those things are just worth anticipating. More broadly, one exercise that I would recommend, this is it's a very difficult habit to learn to do, but I've gotten better about it. And I think it's never been a mistake, which is, you're trying to build something ambitious like a recommender system. You have a sense of what all the components are. And I think the reason why I didn't do it for a while, and I think a lot of people don't do it, is because this involves no coding. So you feel like you're productive when you're writing a bunch of code and you're git push commits and all that. What I think is important is to just say, okay, here are my 6 components, and to just talk to everyone who is dealing with those components and then ask them particular questions. Just simple questions. What data do you have? If I wanted to look back over 90 days, could we do it? How many items does the typical user purchase or interact with? How many items do we have? All these things, because once you have all the components and just some fundamental questions on all of them, questions that will provide constraints on what you can do, you'll be amazed about what that resolves on what you can and can't do. And I think it's a failure case. If you're building something and you're proud of it and you read some blogs about how impressive it is, and then you try to implement it and you get blocked by an engineer, I think that's the data scientist's fault. I don't think that's the engineer's fault. The engineer was always there to talk to you. And so that survey should have revealed that. If they say, I'm saying this because this has happened to me before, where I'm like, can't we do X, Y, Z? It's like, no, we don't have infrastructure for that, So a really disciplined, no code, sort of just take notes, ask people. You'd be amazed about the amount of information that is just on your page by the end of 4 conversations.
Thank you. That's awesome. I'm going to give you a drum roll for that. Okay, so now let's briefly talk about the recommender system that we've all seen in action, and the system that touch upon our lives, right? Like how our lives would be different without them. So Netflix, you already mentioned Netflix, Amazon, Spotify, my favorite. All of these tech giants have exhibited what world-class systems can do for the business, right? So for me, Spotify's recommendation engine has enabled me to discover so much good music that I wouldn't have ever encountered, right? So all that said, it's impractical for startups to emulate what these tech giants have managed to do, right? So the question is, what is practical for a startup to do when looking to deploy a recommender system and emulate some of the success of, say, Spotify?
DJ, I think you're better positioned to take lead on this one.
I could jump in on this one. I mean, there's good news here, which is it is a false hope to want to emulate the big companies. You're not the big companies.
Right.
They have just different resources, different data, all sorts of things. At the same time, all the fanciest deep learning methods that are advertised in papers don't go to those. There was a interesting 2019 paper called "Are We Really Making Progress?" And it was basically a replication study, and it took 18 of the most impressive looking recommender system algorithms from conferences published by Meta and Spotify, all the big companies, and first, right off the bat, they couldn't replicate 10 out of the 18 with a reasonable amount of effort. It was just, they just couldn't figure it out. And these are recommender system experts. Like there's no, you're not gonna take anything away from them for that. Then of the 8 that they did replicate, they got their same results. 6 of them couldn't beat a simple linear model that they had used as a benchmark. Just like a well-featurized linear model, 6 of them lost. Excuse me, I got the numbers wrong slightly. There was 7 of them that they could replicate. 6 of them lost, and then one of them was an actual outlier, did pretty well. But then they just needed to use a more fancy linear model. I forget exactly what they used, and then it was still beat. And these are the fanciest deep learning models out there. And I think what that does is you should be, if you're starting to building a recommender system, don't think about deep learning at all. You can get incredibly far with just SVD, factorization machines, content-based methods. There's all sorts of sort of standard routines which will get you enough. And when these big deep learning solutions were rolled out, to give an example, like the Netflix prize problem that I know that's over 10 years old, but that whole $1 million prize that they put out was only for a 10% increase in mean squared error. So those giant systems, they're going to make a ton of money on that increment. But it's not like you sitting at your startup, hey, if I don't build a deep learning system, I'm going to miss out on a 100x improvement. No, you're going to miss out on a 10 or 20x improvement. And realistically, you're not going to miss out on anything because you can't build the thing that you're saying that you can. All the tuning is going to be a liability. You don't actually have the data that justifies all these like nonlinear effects that you want to pick up on. And the good news is something like factorization machines, which can pick up on second order and third order effects just in a linear fashion, it works great. It works really well. So just go with that. And I would think you just want something reliable. Just to go a little bit further on this, I have learned to hate tuning. You know, I love to be able to put out a model and say, this model has 4 things, and I can almost brute force the tuning on them. I've built fancier deep learning, and they have 50 hyperparameters, and it's just a complete headache. There's a defensiveness built into enjoying models that require low tuning, and that allows you to focus on other things, because there's going to be other problems. There's going to be 1,000 other problems. So if you don't need to worry about a problem like tuning and you can get away with it and there are options to avoid it, do that.
If I could just echo that, like the biggest difference in performance isn't between different types of recommenders or different methods. The biggest difference is between not having a recommender and having a recommender. Like that's the chasm you have to jump across. Once you're there, yes, then you can start making incremental gains by changing out the methods, introducing new data sources, things like that. But just the getting something functioning is actually the most important part. I just have to say amen to everything DJ said about the complicated methods. Like I remember back when data science was still just becoming a thing. So like 2010, 2012, people were getting into. We were seeing the rise of massively parallelizable problems. This is when HADOP and things like that were becoming extremely popular, and everyone was looking for ways to parallelize all of their workflows in order to supposedly address these problems that just couldn't be addressed in single core machines. And I wish I could remember who said it. I'd give attribution if I remembered, but I remember it was somewhere on Twitter. Someone said, most problems that people try to parallelize could actually be solved with a 5-minute walk and a cup of coffee. If you just take the time to think about it a little bit more and say, is there a way I could make this more efficient? You actually can usually arrive at a pretty good solution without all of the compute costs associated with the parallelization. I'd say the same thing is true often, not always, but often of many of the cutting edge like deep learning stuff that happens now. I don't want to minimize those. They're important methods. That there are some problems that can only be solved with those methods. But a lot of business problems are actually very much addressable with very, very simple methods, and just thinking a little bit about how to structure the problem.
Okay. DJ, anything else?
Yeah, I can add a little thing that this got me to think about. So when you mentioned 2010, so it's an odd preference that I've developed in building recommender systems, but I really like papers from the big companies about 10 years ago. Because they were resource constrained in a different way. Their data was smaller. I think there was less pressure to use like deep learning. Like if you want a paper published, it has to have some sort of, which is almost like a confounder. Like, all right, let me take out the thing that is complexifying things unnecessarily. Those recommenders worked. They show strong results. And I found a lot of just really good ideas in those older papers, particularly Amazon. They have a bunch where they were really pushing the frontiers on basically e-commerce recommenders. They're just kind of easy to digest. They are not terribly complicated, and they scale great. I mean, Amazon 10 years ago was still not small, so it's not like you're gonna be like, oh, this is peanuts. I can't, Amazon 10 years ago isn't good enough for me. I promise you, it's fine for your startup. So that's been a weird sort of area that I found some gems in.
Cool. When you look up recommender systems on Google, right, people talk about them as if there are a few fundamental models you can use: collaborative filtering, content-based recommendations, so on. So do you find it useful, Schaun? And maybe you can tell us, do you find it useful to think about recommender system that way? And I'm sure our audience would also love to know a bit about your own personal experience working on recommender systems. So maybe, share that a bit as well.
I can understand why people organize it that way to talk about collaborative filtering, content-based models, things like that. I feel like that presents the proposed solution as the starting point, and I think that's the problem. Any recommender system is basically the embodiment of a hypothesis about user behavior, about what makes users do what they do. Like collaborative filtering, the hypothesis is that user preferences aren't something we can measure directly, but by comparing a bunch of users, we can see where the overlap is, and therefore we can basically find this latent dimension that is their preference. That's one way of thinking about user preferences. But I mean, go to a much simpler example, just with like food delivery. Think of a recommender that recommends the most common item, like picks a user, finds out what they ordered the most of over the last few weeks, and recommends that again. Like if there's a user who like Friday is pad thai night, not every Friday, but usually that's like kind of their thing. But you don't get them to do it every Friday. Sometimes they're busy, sometimes they don't think about it. But recommending them to do that on Friday could actually be a very good strategy for that individual user. So for me, I think the more important starting point is to think about the data generating process. What are your different hypotheses about why a user would act on a recommendation? And that's where you then should start working with your data scientists to start finding approaches, and it may be collaborative filtering or something like that, but finding approaches that then can address each of those hypotheses. People are all for A/B testing, but when it comes to recommender systems, I feel people often gravitate towards this like one ring to rule them all method of maybe it's because recommender systems are expensive to implement, but they want one thing that's going to be that's their recommender system. When in fact, I think the future of recommender systems is recommender systems, plural. That you should have multiple systems and you should be competing them, and not just to find the best one for all of your users or best one on average, but actually to find niches of users who respond to particular systems. So even if a system doesn't work great on average, it might be the only thing that works for 5% of your users. It's the only way you get them to act on recommendations. In that case, it's well worth it. It's the only way you reach them. That, I think, is the direction the technology and the market is heading. And so I think that's the starting point that is the most valuable one, is thinking about your different hypotheses about various data generating processes.
Cool. And what innovations in recommender systems are you most optimistic about right now? Are there, research you think that has strong potential, ideas that you're experimenting with?
As DJ pointed out, a lot of the papers are they're focused on very technical optimizations, and in practice, I don't know that actually results in very many differences in performance, unless you are a big company with established recommender system and you're trying to eke out incremental gains over what you've had before. For me, I think the most interesting development in recommender systems, and I'll freely admit my bias because it's part of what we've been designing at AMP, but this intersection of more traditional recommender systems like collaborative filtering and reinforcement learning systems, where a typical like multi-arm bandit you're not going to use typically a multi-arm bandit for a recommender system where you have 100,000 different items you can recommend. It's too many options for a bandit to explore. But you can use a bandit to explore maybe product categories, maybe brand preferences, depending on how many you have. Definitely preferences regarding that metadata of how to frame, like what value proposition speaks to them, what images work best. And being able to combine those two things, not only to augment the performance of any individual recommender system, but actually you could multi-arm bandit recommender systems. And that, I think, is an interesting space to be explored. I personally am betting that is one of the trends going forward.
Yeah, I can echo that a bit. I think a lot of recommender systems, they sort of accept the flaws of whatever metrics you show up to the table. These things being like, just using observations as surrogates for sort of actual causal questions. And so I similarly get excited about methods that address the causal question directly with something like randomization across actions and contextual bandits. Again, you can't use that solution, again, to echo Schaun a little bit here, you can't use that solution across the board. You have to sort of choose. The action set that you're picking from needs to be small. You're going to need to pepper data across all of them. So we're thinking in terms of choosing between recommender systems, and then the recommender systems sort of inform each other. So that's interesting. There's other stuff that I sort of momentarily get excited about. I've learned to bring a lot of skepticism to the table on it, but these problems are just so ubiquitous that I'm desperate for a solution. So one example is just handling sparse rewards, long-term signals. I mean, that's been around forever. One of the problems that we're thinking about AMP is like, sometimes we're thinking about this like goal event, which is this rare thing, like a purchase right at the end. But the user is doing, they're exploding with all these micro actions before them, which are sort of correlated with the goal thing. And so there's these efforts to sort of construct these like aggregate, probabilistic funnels towards the end. Those things are kind of interesting. I've read a couple papers on them, and they get like very little love and attention, because once you start solving that, you end up creating sort of a Frankenstein reward that you can just look at and be like, all right, well, I don't think that's the next transformer innovation. But I'm always paying attention to that. Another area which is interesting, which is hard, is doing sequential decisioning is very hard. Especially in production systems. So not thinking about what item to recommend, but maybe we're going to put together a whole sequence of recommendations that ultimately will produce a certain preference. That is a very hard problem. I think if you do it, you need to truncate the amount of actions that you think. So a paper that I'd be willing to look at would only not one recommendation, but maybe 2 or 3 in a sequence. And there was a paper which talked about it. It's called like deep exploration, and it does exactly this. It turns the problem into a sequential decisioning problem, and it's pretty shallow ultimately. They use simulated data at the end of the day, so I have to be like, well, okay. I mean, that's good, but I mean, there's more there. So I'll be paying attention.
Well, awesome. I think that brings us to the end of this really rich session. I mean, I had a great time. I think I learned so much. So, really appreciate your time. I'm just gonna give us a cheer.